So, they go into parabolas first again because we are most comfortable. Here's the idea of a parabola, some of which we've seen before. Axis of symmetry you can see in there. Few new ideas. First of all, we're going to have to be comfortable with the idea of having a horizontal parabola, which is not a function because it doesn't pass the vertical line test, but we're still worried about things like that, relations that are horizontal parabolas. And then we are also introducing the ideas of a focus and a directrix. Those are very important because the definition of a circle, for example, is the set of points equidistant from a center point. We should all be comfortable with that definition of a circle. The definition of a parabola, though, is basically the set of points equidistant from a line and a point not on that line. So our vertex, let's go in a different color, the vertex of our parabola would be here, and the parabola is going to look something like this. What this is saying is this distance is the same as this distance. This distance is the same as this distance. This distance is the same as this distance. And on and on and on and on and on. So that's how we define a parabola, is that every point on the parabola, every single one, is equidistant from the focus and from this line we call the directrix. That's how it's defined. Now, why are parabolas important? Have you ever heard of a flashlight? In a flashlight, basically what you have is like a three-dimensional parabola. Okay, it's like a parabola that you just spin around, making some sort of shape like that. And what's needed is the bulb is supposed to go right at the focus. Reason being, if you go from the focus to any spot on the parabola, the reflection is straight out, and it doesn't matter where you go. So the light from the bulb goes in 360 degrees, goes everywhere, but no matter where it runs into the parabola, it's going to hit the parabola and bounce straight out. And obviously the idea for a flashlight is that the light doesn't go everywhere. It goes in, as best you can have, a straight line. This page, very, 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 very important. You're going to be referencing this page a lot while you do your homework. Okay, we have a lot of formulas. We have formulas for a vertical parabola with vertex at the origin. Formulas for a vertical parabola with a vertex somewhere other than the origin. And this we should be comfortable with. The only difference here than what we've seen before is when we did parabolas before, the vertex form of a parabola was just a times x minus h squared plus k. That should look familiar. You may not like it, but it may look familiar. The only difference is that now, instead of just saying a, we say that's 1 over 4c. Why do we say it's 1 over 4c? Because that number c, whatever it happens to be, is going to help us find the focus and the directrix for our parabola. So that was vertical. Then we have these formulas for horizontal parabolas, vertex at the origin, vertex somewhere else. Notice that it's x equals 1 over 4c y squared. The x and the y's just switch. And the focus is a little bit different. For a vertical, it's 0c, horizontal, it's c0, etc., etc., etc. So you can see these formulas. You're going to have to reference these a lot as we go through the problems. Part A. What is an equation of the parabola with vertex at the origin and focus 0, 1/2? So first thing we have to determine, is this parabola vertical or horizontal? We know we have vertex at the origin, and that our focus is at 0, 1/2. And if you look and see at the picture and understand where a focus is supposed to be, we know the parabola is going to look something like that. It's going to be vertical.
Where would the focus be on a horizontal?
Right. If you go from the vertex, the direction you go to get to the focus is the same orientation the parabola will have. So if the focus was at 1/2, 0 over here, that would be a horizontal parabola. But the focus is got the same orientation from the vertex as the rest of the parabola. If it's vertical, it's vertical. Horizontal, it'll be horizontal. So the fact that the focus is directly above the vertex tells us it is vertical. And we want an equation. We know that the origin is our vertex. So looking at the previous page, we know the general form is y equals 1 over 4c times x squared. But knowing that the focus is at 0, 1/2 tells us what c is. What is c? Referencing again that previous page.
1/2.
So we know, again from referencing the previous page, c is 1/2. So an equation, y equals 1 over 4 times 1/2 x squared. What does this simplify to? 1/2. So that's our equation. Y equals 1/2 x squared. So now we have to move on to part B. What are the focus and directrix of the parabola with equation y equals 6x squared? We know that's a vertical parabola, just from the way the equation is set up. We know that the vertex is the origin, because there's nothing added to the x, there's nothing added at the end. So we know the vertex is 0, 0, but they're just asking for the focus and the directrix. But knowing what we know, it's got the same general form as in part A. Y equals 1 over 4c x squared. So what can we do? We can say that 1 over 4c in our particular example here should be 6. Be quiet. So we solve this. We get 1 is 24c. So c must be 1/24. And again, looking at the previous page, now that we know that it's a vertically aligned parabola, vertex at the origin, and the value of c is 1/24, we know that the focus is 0, 1/24, and that the directrix is going to be y equals negative 1/24. What is an equation of a parabola with vertex at the origin and directrix x equals negative 1/8? So again, we have to determine, is it vertical or is it horizontal? If the directrix is negative 1/8, that line is going to look like this. And if your directrix is vertical, your parabola is going to be horizontal, and vice versa. If your directrix is horizontal, your parabola is going to be vertical. They always go opposite. So we know we're dealing with a horizontal parabola, which is very helpful because now when you go back a couple pages to look at the formulas, you know which formulas to look at. So we know that we're dealing with the situation where we've got x equals 1 over 4c y squared. Moreover, we know that c is positive 1/8. And we know that from the equation for the directrix. If you look at the formulas a couple pages ago, it tells you the directrix for a horizontal parabola is x equals negative c. So this right here tells us that c is 1/8. So we've done the difficult part. The nice part is, it wasn't really that difficult, hopefully, because now we know that c is 1/8. So we just say x is 1 over 4 times 1/8 y squared. So x is 2y squared. 4 times 1/8 is 1/2. 1 divided by 1/2 is 2. Part B. Part B, this one again, we want to determine if it's horizontal or vertical. Since they give us the equation, it's easy. Since the y is the one that's squared, we know that is a horizontal parabola. They want to know the vertex, the focus, and the directrix. From the form that it's in, it either is obvious now or will become obvious to you after doing these problems for a little bit, that the vertex is the origin. 0, 0. So then we need to know the focus and the directrix. Again, we're dealing in the general form like this. The equation given is this. So we know 1 over 4cy squared equals 3/5 y squared, meaning 1 over 4c must equal 3/5. When you have equations like this, you can cross multiply. So I've got 12c is 5, so c is 5/12. So my focus is the point 5/12, 0, and my directrix, which I will abbreviate as dir, is going to be the line x equals negative 5/12. So they wanted vertex, focus, and directrix. They've got vertex, focus, and directrix. So how did we know the vertex was the origin? For a horizontal parabola, the general form, if the vertex were not the origin, is y minus k squared plus h. So there's nothing like this, there's nothing like this, so I know that the vertex is 0, 0, which is the origin. A thinking problem. The mirrored reflector of a flashlight is 16 centimeters across and 10 centimeters deep. How far from the vertex should the light bulb be positioned? So we said before, the light bulb should be in the same exact spot as the focus. Should be in the same spot as the focus. All they tell us is that the mirrored reflector is 16 centimeters across and 10 centimeters deep. All right, I told you that that means it's parabolic, so we get to assume it's parabolic. In a problem like this, the trick, which isn't really that tricky, but the trick is that we know it's a parabola. We know it's 10 centimeters deep, so this is 10. We know it's 16 centimeters across, so this is 16. What we have to do to figure this out is put the parabola in the xy coordinate plane. The nice part about this trick is that you can do that and make the vertex whatever you want. Noticing that I chose to set it up so that my vertex is 0, 0. That means I know this point here is 8, 10. This point here is negative 8, 10. The 10 should make sense. The 8, though, maybe not as much. We know it's 16 centimeters all the way across. We know the y-axis is right in the middle. So 8 this way, 8 that way. So negative 8, 8 for a total of 16 centimeters across. So now all we have to do, you could have also chosen to align this as a horizontal parabola if you wanted. I obviously chose to set it up as a vertical parabola, which means that the equation I'm working with, y equals 1 over 4c x squared. To find out where the focus should be, I need to know what c is. Correct? Correct. The nice part is, I can just take this right here, That is an x and a y. 10 is 1 over 4c times 8 squared. I now have an equation whose only variable is c, so I can solve. I get 10 is 64 over 4c, which is 16 over c. Multiply each side by c, I get 10c is 16. Divide each side by 10, I get that c is 1.6, which would tell me that my focus is the point 0, 1.6, but that's not what they asked. They asked, how far from the vertex should the light bulb be positioned? And that distance is 1.6 centimeters. So here, what are the vertex, focus, and directrix of the parabola with equation y equals x squared minus 6x plus 15? That is a quadratic equation given in standard form, which is pretty useless. You could graph it, and you could figure out what the vertex is, sure, but not the focus and the directrix as easily. What we want to do is rewrite it in the form y equals 1 over 4c times x minus h squared plus k. This is a vertical parabola. Appreciate you. So the question is, how do you go from standard form of a quadratic equation to vertex form? And the answer, unfortunately enough for some of you in here, is by completing the square.
All right.
So y equals x squared minus 6x. You kick the 15 to the curb. What number must I put here to complete the square? Plus 9. You have to remember that to complete the square, you have to make sure that this coefficient here is a 1. And then you take whatever this number is, divide it by 2, and square it. Negative 6 divided by 2 is negative 3. And if you square that, you get 9. Now, since I add 9 here, I must subtract 9 here so that everything is balanced. So that in the end, I've done nothing other than allow myself to now write the equation in the form x minus 3 squared plus 6, telling me that the vertex is the point 3, 6. And now I want to find out the focus and the directrix. That's where I have to look at this part of the formula, which is this number right here. So 1 over 4c equals 1. Multiply each side by 4c, divide each side by 4. So now I have that c is 1/4. Now the trick with this one, which I call a trick, it's not really a trick, the vertex is not at the origin. Most of the problems we've been looking at today, the vertex has been at the origin, which makes finding the focus and the directrix incredibly easy. Because if you have c like this, the focus would be 0, 1/4, and the directrix would be y equals negative 1/4. But if you look at the formulas on that page with all the formulas, when the vertex is not at the origin, then our focus is actually, our c is 1/4, so it's you go from the point 36, you go straight up 1/4 of a spot. So our focus is 3, 6.25. From the vertex, straight up 1/4 of a spot. The directrix, which I will then abbreviate as dir, you only get it once. The directrix is going to be y equals, it is from the vertex straight down c. So that's going to be y equals 5.75. And again, it's just looking at the formulas on that page. If the vertex is not at the origin, they tell you on that page that the focus is h, k plus c, and that the directrix is y equals k minus c. So I initially called it a trick. It's not a trick as much as it is just making sure you're paying attention to the details.
And we'll get the equations.
So, here, this problem, multiple choice, and not a particularly difficult multiple choice, which is an equation of the parabola with vertex 10, 2 and focus 10, 1. Start by seeing, is the vertex enough to get an answer? If the vertex is 10, 2, then it should be x minus 10 here, and it should be plus 2 here. So that one's wrong. C is wrong, and D is wrong. So just looking at the vertex, you can figure out that the choice is B. Now, if that weren't enough to figure out the choice was B, then you would have to realize that C equals what? Negative 1. C would be negative 1. So then our equation would be y equals 1 over 4 times negative 1 times x minus 10 squared plus 2, which is choice B. Is everybody clear why C is negative 1? From the vertex, 10, 2, you went down 1 to get to the focus. So that parabola is going to look like that. That's why it's a negative.